I work in something called string theory, which we think is the theory that eluded Einstein for the last 30 years of his life, the theory of everything, the theory that explains the Big Bang, the formation of stars, galaxy, formation of the Earth, life. I'm a physicist working in the theory of everything that will allow us to, quote, read the mind of God. These are Einstein's words. The theory of the Big Bang, the theory of creation itself, the theory of everything. No, everything. Because from physics comes chemistry, chemistry comes biology, and from that comes our universe.
In
That's
space
right.
and time.
Gravity, light, the nuclear force. There are four fundamental forces of the universe. There's the gravitational force, which keeps us here, the electromagnetic force, which lights up our world, and the two nuclear forces. We want a theory that explains all four. What does it mean for me? The physics of the future. That is, we physicists create the future. We're the ones who understand what is possible, what is not possible, and what is plausible. How does that affect the average person? Especially for people who are philosophical or religious, they want to know, what does it all mean? I mean, where did I come from? Where's the universe going? They want to know the answer to the big questions, the question of meaning. And that's what we physicists do. Oh, yeah, that too. That's a byproduct of what we do, is look for extraterrestrial intelligence. Yeah, people think that physics is for eggheads, that it's just doing equations on a blackboard and totally divorced from the average person. They don't realize that everything about their life, about electricity, about magnetism, about the nuclear force, about industry, everything comes from physics. But the average person thinks that physics is for eggheads. It's for equations you put on a blackboard in a cartoon. Nope, it's everywhere. We're not alone because the galaxy has 100 billion stars, of which maybe 10% have planets that are Earth-like or are similar to Earth. But the question is, can they visit us? A Saturn V rocket would take 70,000 years just to reach the nearest star. So I'm a physicist. We look at that. Space warps. Is it possible that a flying saucer race could create a space warp so they can visit us?
Space warp?
Well, gravity bends space all the time. The question is, can you bend space enough so that you can go faster than the speed of light so you can visit the nearest star? That's a question mark. We physicists look at that, but we have no definite answer. But it's possible. Well, there are three types of observations. The close encounters of the first kind is when you see something in the sky, first kind. Close encounters of the second kind is when you have something tangible, an engine, a body, a wreckage of a UAP. That's second kind. Close encounters of the third kind is when you actually encounter them and shake their hand. Now, where are we? We're at close encounters of the first kind, where we see things floating in the sky, but we don't know what they are. We don't have anything tangible. Now, in science fiction, we've captured the flying saucer. We have the aliens in a case, so on and so forth. That's the movies. We have yet to see an alien in a laboratory. We have yet to see an alien ship. In other words, people say, I saw something. Now, what does that mean? I'm a physicist. We go where the observation goes, and we have no observations to verify what you saw. Except, of course, sensationalists who say, I've seen the bodies. Okay, show us. But no, I'm open to the possibility. 95% of the sightings we can explain using the known laws of physics. 5% are either optical illusions or they are evidence of visitation. You can't rule it out. So I'm open to the idea that maybe they're here. Encounters of alien technology, we think, but we haven't yet seen a close encounter of the second kind. When that happens, that's a game changer. That's the traditional excuse for not revealing these things. But the other excuse is that it's a cover. It's a cover for the stealth bomber. It's a cover for the fact that the military does experiment with aerodynamically novel forms of transport. And so those are the reasons why the military keeps it a secret and actually lies about these things. But now it's leaking out. Congress, the President of the United States, they're demanding these sightings to be declassified. So we physicists now are analyzing them to see whether or not they're really real or not. Well, for example, take a look at Alpha Centauri, the closest star system to the planet Earth, right?
How far away is that?
4.5 light years. And if you take a look at the Alpha Centauri system, the closest system to the Earth, you have red stars that could have life on them. We're not sure. They're not super hot, super large, in which case it would be very difficult to get life forms off the ground. But the point I'm raising is that the Milky Way galaxy, our backyard, has 100 billion stars. And the probability of life existing among those stars is almost 100%. The question is, can they reach us? That means, is it possible to create a space warp such that you can break the light barrier so that you can travel across the galaxy and visit the Earth? It's theoretically possible, yeah. But of course, you need energy, fantastic amounts of energy. But the laws of physics do allow for the possibility of space warps. I mean, you've seen space warps on Star Trek, but where did Star Trek get the word space warps? It comes from physics. Yeah, which is very unusual. It's the only one we've seen so far. Oh yeah, that's one of several theories that a civilization that advanced would have tremendous energy needs. Mm-hmm. And the easiest way to get energy is by encircling the mother star with an envelope. And the envelope then would absorb most of the energy. In fact, that was an episode of Star Trek. They meet a star that is totally enveloped by a metal shell. The aliens left it centuries ago. But, it can't be ruled out. No, they think that it's probably an orbiting globe that eclipses the mother star. Rather than envelops the mother star, it simply goes around the mother star and eclipses it. That's the theory. Because of dip in the intensity of light.
As far as we see it.
As far as we see it, right. Planets are not that big. Planets are about 1%. Like Jupiter is about 1% the size of the sun. So the sunlight would drop by about 1 or 2% if Jupiter goes in front of our sun. So this is much bigger. It's huge. Well, the universe came from the Big Bang. The question is, where did the Big Bang come from, right? A Big Bang is a cosmic explosion that took place around 14 or so billion years ago that created the expanding universe.
How do we know that happened?
Because we have evidence of this expansion that took place, 14 or so billion years ago. We see the stars moving away from us. So think of a big balloon with points of light on the balloon, and the balloon is expanding, and the stars are moving away from each other. Mm-hmm. That's what we see today. Not moving toward each other. All the stars are moving away from each other like the sphere is expanding. And so we believe in the Big Bang Theory, and we believe that the universe is expanding rather than contracting. Well, we live in a 4-dimensional universe, 3 dimensions of space, 1 dimension of time. We live in a 4-dimensional universe. But in string theory, we believe that there are 11 dimensions altogether. I came up with string field theory, which is one of the branches of string theory, right? It says that what is a proton? What is an electron? They're nothing but vibrations of a string. So from a distance, this looks like a point particle. From a distance, this is an electron. But if you could magnify that, we find out it's not really a point at all. It's really a vibrating string. And each vibration corresponds to a note. So this would be a proton, this would be an electron, this would be a neutron, this would be a neutrino. That's why we have so many subatomic particles. That's right. Everything is basically a vibrating string. So when the string vibrates in this direction, we call it an electron. If it vibrates in this way, we call it a proton. So why do we have so many subatomic particles? How many of them are there? Hundreds. We've seen hundreds of subatomic particles. And how could Mother Nature be so malicious to create a universe at the fundamental level based on hundreds of different kinds of strings vibrating in different directions? Well, it's really just one string. One string that can vibrate in different modes. Each mode is called a particle. We don't know why things are. I'm a physicist. We just try to figure out the way things really are. But it will explain why there's so many particles. We used to think there was an electron, a proton, and a neutron, and that's it. That's it, period. Nope. We've seen pi mesons, we've seen lambda particles, omega particles, hundreds of subatomic particles. Why do we build atom smashers? Outside Chicago, outside Geneva, huge, gigantic atom smashers smashing atoms apart. Why? Because then from the debris, we begin to figure out these vibrations are particles. We can categorize them. We can give them names. And that gives us, a theory of everything. So we have what is called the Standard Model, which explains all the subatomic particles other than gravity. And we create these particles with their atom smashers.
So went around the
That's
world
right.
to figure out.
That's a Large Hadron Collider, right? But now we realize that there's another octave. There's another layer even beyond what we see with the Large Hadron Collider. Dark matter. Dark matter is invisible matter that surrounds the Milky Way galaxy. And we don't know what it is. There's a Nobel Prize waiting for somebody who could figure out what dark matter is. It's invisible matter that surrounds the entire Milky Way galaxy. We think, though we cannot yet prove, that it's nothing but the next octave, vibration. In other words, this would be the lowest vibration, which corresponds to an electron, but there are other vibrations much bigger, and they would correspond to a higher octave. This is a guess, but it turns out that when you do the math, and you look at the vibration of a string, and you look at the higher vibrations, some of them are invisible. In other words, they don't interact with light. Now, we know that this interacts with light, therefore we can see it. Some of the higher vibrations are invisible. And so we think that's what dark matter is. Well, we don't know, but there are theories. String theory is a theory even before the Big Bang. It's a theory of everything. The Big Bang, in some sense, is a misnomer because it disguises the fact that we're ignorant. We're ignorant of what caused the thing to bang. String theory, there was no bang. That is, it did collapse, if you go backwards in time, it did collapse to a very small thing and then came out again. It bounced. So we think that there could be a bubble bath of universes. And the bubble is expanding, and that's called the Big Bang Theory, which fits all the data. But we think there are other bubbles out there. In other words, string theory says that we live not just in a 4-dimensional world, but in a 11-dimensional world. These other dimensions we cannot see, but we think that the universe coexists with other universes. There's a bubble bath. Think of bubbles, soap bubbles floating in the vacuum. So let's say this is the sun.
Yeah.
And these are planets, asteroids, whatever, and they're going around the sun.
Mm-hmm.
Why? Why are they going around the sun like that? Okay? It's because this exerts gravitational force that is pulling these things toward the sun. Mm. The Earth is just one. Asteroids are none of the other. Saturn, Jupiter, they're nothing but planets going around the mother star. And so then the next question is why? Why is it that planets are going around the sun? It's because the sun is warping the space around it, is creating a shallow depression. Space is not flat. This is Einstein's achievement. You go in this direction, seems flat. You go in this direction, everything seems to be flat, right? But no, the Earth, for example, is round, but it looks flat, but it's not. The universe looks flat, but it's not. It's curved. And that's why planets go around the mother star, because gravity is a byproduct of the warping of space, and that's why we are sitting on this chair right now. Why are we here? How come we're not flying in outer space? The Earth is spinning, right? Mm-hmm. If the Earth is spinning, we should be flung out into outer space. So how come we're here? What is gravity, though? That's just a word, right? Why is it pulling us in? Einstein says that the reason why the Earth is pulling us in is because the Earth warps the space around us and is pushing us into the floor. That's why the solar system works the way it does, because the sun grabs the planets and forces the planets to move in a curved line because it's curved space that is causing it to move this way. Then the question is, are there other stars? Yes. Are there other galaxies? There are billions and billions of planets out there. We think that now we're saying that maybe there are other bubbles out there. A multiverse. a multiverse of universes, parallel universes. In fact, word multiverse has gotten into the literature. Comic books now refer to the multiverse, Spider-Man and things like that. So it's even part of the vernacular, the common language of the average person, that we believe in parallel universes. So yeah, these parallel universes come from physics. That's right. If this star becomes so massive that its gravity is so great that it pulls and we now believe that at the center of almost every galaxy we see, and there are trillions of galaxies, we think that at the center of these galaxies, there's a black hole. If you look in the direction of Sagittarius, the constellation Sagittarius, there's a black hole there. So tonight, go outside, look for the constellation Sagittarius, and there's a black hole at the center of our own backyard that holds the Milky Way galaxy together. Well, we think that it's a remnant of the Big Bang, that when the Big Bang exploded, clusters of matter begin to contract other clusters of matter, and this is where the galaxies and the planets come from. The condensation of the matter ejected out of the Big Bang gives you the galaxies, the solar systems, and the planets. We're not sure about exactly which came first, the galaxy came first or the black hole came first. But let's assume for the moment that the black hole came first. Gas concentrated into a small area called the black hole, and then it drew all the other stars and galaxy around it to create the Milky Way galaxy. We're not sure, but that's one possibility of where it came from. And where did that come from? That in turn came from the explosion that created the universe roughly 14 billion years ago. That's right, and you never get out again. If this is a black hole, there is a ring or a sphere surrounding it, a point of no return. You go toward the black hole and you pass this ring, and then you go into the black hole, never to be seen again. It's a point of no return. Well, we've never seen it happen, but we can calculate the escape velocity. In other words, if you want to leave the Earth, how fast do you have to move to leave the Earth? 7 miles per second. Our astronauts travel 7 miles per second to reach the moon. Okay? That's called escape velocity. So every gravitating piece of matter has an escape velocity. For the Earth, it's 7 miles per second. What about the escape velocity of a black hole? It's the speed of light. So you go in, but you never come out. That's why it's called black holes. I don't know how big they are. We think at the very center, it could be very small. We're not sure. No one's ever been there because if you go past the event horizon, you never come out again. I would say that it's an entrance. It's a gateway, perhaps to another universe. We think, for example, if I have a warp space and you fall into warp space, if the warp space is powerful enough, it may come out again on the other side. Mm-hmm. So there may be another universe on the other side of a black hole. We're not sure, of course. If you want to go to Alpha Centauri with a Saturn V rocket, it would take 70,000 years to reach the nearest star with our most powerful rocket. Very impractical. You need a shortcut. And that's the gateway called a wormhole, which is very similar to a black hole. A little bit different, but very similar. Since I was 8 years old, I've been studying the universe. When I was 8 years old, a great scientist had just died. It was in all the newspapers. And the newspaper said that he failed on his last try to create a theory of everything. So I was fascinated by this idea that this man was attempting to find the final theory.
You're talking about Einstein.
That's right. Later, I found out the man's name was Albert Einstein. And at that point, I said to myself, that's for me. That's what I want to work on. I want to be part of this great journey to complete Einstein's dream of a theory of everything. And that's what I do for a living. I work with Einstein's equations. Most of my family were Buddhists, coming from Japan. But my father was a Christian and put me in Sunday school. So I had the benefit of two religions as a child. Now I'm a physicist. And physicists are, quote, agnostic. They don't take a position. They simply go where the physics takes them. Into areas that are distasteful, mysterious, whatever. You go where the evidence goes. And that's what I am today. In other words, we have the laws of physics. We have string theory, which takes us to the instant of the Big Bang, and even before the creation of the universe. But then the next question is, where does string theory come from? Okay? At that point, we have to say that that's where our ignorance takes over. We simply don't know. I would say the answer is probably no.
Probably no.
That's right. Simulation theory is basically saying that the universe is a puppet show. And there's a script. We're living out the script because somebody is pulling our strings. First of all, that violates quantum theory. Quantum theory believes in probabilities. Probabilities that I'm sitting here today, probabilities that maybe one day I'll go into outer space. We can calculate the probabilities of atomic events, chemical events with accuracy that is incredible. But simulation theory is not one of them. Well, my personal point of view is there's option 4 that you don't mention. And option 4 is that there is no simulation at all. That all this talk is nothing but fairy tales that we tell our children to amaze them about the universe. But you see, the universe is based on probabilities. Probabilities that uranium will fire, for example, which gives us nuclear weapons. Probability that hydrogen can fuse, and that gives us stars. So the universe is based on probabilities, not on simulations. Well, I think the answer to that is that what you consider to be reality is really a partial fiction. That your senses are limited by what your senses can retrieve from the outside world, but it's only a teeny-weeny little fraction of what actually exists. Look at the electromagnetic spectrum of light, for example. You can't see all the ultraviolet radiation, the infrared, X-rays. This room is full of realities that you can't see. Most of what you see is a fragment, a teeny, eensy-weensy little fragment of reality. You can't see cosmic rays. You can't see ultraviolet radiation. So what I'm trying to tell you is that you live in an illusion. It's a good illusion for survival. But in terms of being able to see the full spectrum of reality as it exists, no, there's no way. So you think reality is everything. Nope. It's only a tiny, tiny, eensy-weensy little fragment of reality. And then talking about this reality, that's a fantasy on top of a fantasy. The first fantasy is that you think that what you see is real and everything. That's the first fantasy. The second fantasy is there's a fantasy within the first fantasy. So you're going layer upon layer of fantasies. Now, let me give you another example. Let's say you hear rustling in the forest. You think it's a tiger there. 9 times out of 10, there's no tiger there. But how come your senses are constantly alerting you to the tiger? And that is evolution. Evolution gives you the ability to see things that are not really there at all because it's good for survival. One time there is a tiger and it saves your butt. In other words, why are we here today? We're here today because our senses are overactive. Our senses think there's a lion, there's a tiger there, when there's no lion or tiger there at all. But it was good for our survival. Okay? So our senses are only necessary for our survival. That's why we cannot see infrared, we cannot see ultraviolet, we cannot see the whole spectrum of reality, radio, everything. We can't see it all because it was not necessary for our survival.
What?
But I think each of us create our own meaning. Survival is important for the universe because survival writes history. If there's no survival, there's nothing to write. There's no memories, there's no stories to tell, nothing. It's just the vacuum of space. The olfactory nerves of a dog are infinitely better than our olfactory nerves in our nose. We're talking about the meaning of life, for which I have no answer. Sorry about that. I'm not even sure if the universe has a point. But my personal attitude is we create our own point. We create our own world, and meaning within that world. It could be different from another person's meaning and understanding of the world, but it's good enough for me. Yes, and I think there's a reason for that. And the answer is evolution. What holds animals together? The alpha male, the top dog. As humans became more intelligent over millions of years, humans bicker. We argue. We challenge the leader. And then tribes would fall apart because you need some glue. You need some glue to hold it together. And if everyone becomes intelligent uniformly, there's no glue anymore. Everyone bickers, I'm the leader, no, I'm the leader, so on and so forth. So what happens is one person comes up and says, I'm stronger than you, and I talk to somebody even stronger than me, God. And if you disobey me, then God will strike you down. In other words, God is a glue. God is a glue that holds sentient beings together when there's no reason to hold them together anymore, and they bicker, and the tribe falls apart. What holds the tribe together? God. Who is God? Well, God is not here, but the Son of God is here, and the Son of God says, you got to do this, you got to do this, you got to do this, and you got to obey me. Why? Because I'm the messenger. I'm the Son of God. So I think religion has a definite purpose. The purpose of religion is a glue to hold sentient, intelligent beings together. Consciousness, I think, is a question of awareness, the ability to create ideas about, why. I mean, what does it mean? Meaning, to give meaning to things. Otherwise, things become meaningless. So I think that's the purpose of consciousness, is to give us an awareness of meaning. Probably not. However, we have this instinctive urge to explore, to look for new territories and new ideas. And that is what I think keeps us going. Animals do not have that. You can't tell a dog, aren't you thrilled that we're going to this new house, this new whatever, right? And dog says, no, just give me my dinner. So I think that humans are different. The purpose of the front part of our brain, the cerebral cortex, that holds us together, is a time machine. It asks the question, what's going to happen in the future? If you don't believe me, go to your dog tonight and ask your dog, what did he do last night? And the dog will just bark. No interest in what's happened yesterday, what's happened tomorrow. We constantly think about the future. We can't help it. We are constantly thinking about what's for dinner tomorrow, who's my friend, who's my enemy, what am I going to do next year, what college am I going to go to? We are obsessed with the future. That's what separates us from the animal kingdom. Animals do not care about the future. They just care about survival. We, on the other hand, are obsessed with the future because that's where our survival lies. And why is that? Because we don't have claws. We don't have fangs. We don't have huge muscles. We can't run very fast. We can't fly. We're not like the animals. We are dependent upon the front part of our brain. And that's why we ask these questions that you just asked. Why are you asking these questions? Because you're programmed to ask these questions. Animals are not. Yes, I think that is a definite problem. Right now, I think a lot of our robots have the intelligence of a bug, an insect. They don't plan, they can't articulate their thoughts and so forth, but they carry out orders very well. But eventually, it's only a matter of time before they become as smart as a mouse, then as smart as a rabbit, then as smart as a dog or a cat, and finally as smart as a monkey. At that point, they are potentially dangerous. No, you cannot talk PhD physics with them. They're programmed. They're programmed to have certain ways of thinking about certain things, but they're not original. You can't come up with a new theory of physics talking to a robot. They basically take what is programmed into them and work with that. Now, eventually, they may become creative, okay? But I think that's going to take several decades before we are at that point. Robots right now take what is available to them and rearrange things, like writing a book. Oh, yeah, but we come up with new ideas on the basis of what did exist before. In other words, something new, but basically a rearrangement of something that already existed.
So I'm saying,
well, art, the bottom line of art is mimicry. That's the bottom line of art, except you arrange things in an original way, so it looks fresh.
He took the existing laws of physics, which
were negligible.
And he proposed
there were no laws of physics before Newton. And he asked himself a question, how come the Earth goes around the sun? And he came up with an idea that was totally different from what people had thought about before. He came up with calculus. He came up with the inverse square law. Well, creativity of a robot is imitative. Now, there's nothing wrong with that because, of course, imitative artwork is still artwork, but it's imitative. That many of the new laws of physics are imitative, and you rearrange them and combine them in different ways. So it's possible that the big breakthroughs of the future will be guided by breakthroughs of the past. There's nothing wrong with that. I'm concerned about AI in the larger perspective that one day they can learn to do things that are bad, learn to kill, learn to maim, to harm people. Realize that every invention that we've made in the past, like the bow and arrow, could be used for good and bad. Everything, okay? The bow and arrow could be good for game, for food, for eating, but a bow and arrow could be good for slaughtering your next door neighbor. Any new invention has a double-edged sword to it. And so I think that so far, most of the applications of artificial intelligence have been positive. We're talking about labor costs. We're talking about creating wealth. We're talking about making things faster, cheaper, better. That's all great. But you can also create artificial intelligent weapons as well. And the battlefield is where it's happening. And if you take a look at what's happening in the Ukraine and Russia, already we're talking about aerial weapons that can use wires to lock onto their target. Mm-hmm. And they use artificial intelligence to guide them with this wire. And they cannot be stopped using the usual techniques. Probably, if you take a look at empty space, we now believe that empty space is frothing with little bubbles that pop into existence and then annihilate and go back into nothingness again. So even pure nothingness is chock full of activity. And one day, we think, one of these tiny little bubbles decided not to go back into the vacuum, but to keep on expanding and expanding, and that became the Big Bang. And so the theory says that the universe is dynamic and that universes are being created all the time. Well, I think there's evolution, and evolution did create life forms that are single-celled, multi-celled, and then cells with a nervous system like fish, and then fish became land moving organisms. So I think there's a linear progression.
But you don't believe...
I think it's a fairy tale. I think it's a very compelling fairy tale. But I think that even the people who teach religion realize that it's a metaphor, that we don't really mean 24 hours in a day, because that deals with the earth. In the universe, there could be other worlds where a day is not 24 hours. A day does not look like what the Bible says in Genesis. So I think it's a way to organize your religion into a way that is digestible and people can understand it. And it touches people, which is the purpose of religion. The purpose of religion is to touch people, to bring them together into a commonality. And that's what the story of Genesis does. Religion, in some sense, is a way to help people, to show people guidance, the good life, so that you don't terrorize other people, that you make life better for other people. Not that it explains the meaning of existence, but it gives you a reason for existence. No, I'm agnostic. I believe that there's a lot of truth because it's a way of behaving. It's a way of learning how to be good to your neighbor. It's a glue that holds things together. Not that it gives meaning for life, but it shows the way. Well, I was in the United States Army for 2 years, And at that point, I had to face death, and I had to face war. It was the height of the Vietnam War. There were 500 GIs dying every week. Life magazine published an issue where they had the pictures, just the pictures with no commentary, of all the GIs that died that week. With no commentary, no I told you so, just the pictures of those people that died. And then I realized that I would have to put my life on the line because my number was up. And people were going into the military. And people were realizing, well, war is the way people, work out their differences. But then I began to realize, being in the military, that there is a morality there. I began to realize that the people that we were fighting had their own religion. They had their own way of looking at good and evil and whatever, and they were willing to sacrifice their life for their own freedom. I began to question religion at that point. Is it just a glue that holds people together? Is there a deeper meaning to the whole thing? So one day I was learning how to throw hand grenades, and our sergeant, who was explaining to us how to throw a hand grenade, had scars on one side of his face, big scars on his neck. And we asked him why. And he said, well, one day a little Vietnamese boy came up to him. And the Vietnamese boy says, candy, you want candy? And the GI says, no, get away from me. I don't want candy. Well, the little boy showed what was in his hand. It was a hand grenade. It was not candy at all. And the little boy threw the hand grenade at the sergeant. Well, the sergeant immediately saw what the danger was, and he hit the ground as soon as he could, flat on the ground. The grenade exploded, and one half of his body got saturated with shrapnel. And then you have to ask yourself a question. Why would a young boy do something like this? It's because he believed in something. And I think there was a real big lesson for me. And that is, you have to believe in something. You have to believe in the goodness of men, and also the fact that men can do evil. And you have to fight for what you think is right. And therefore, it's not just a question of we're number one, we're going to win this war. I used to sing a song in the morning, I want to go to Vietnam, I want to kill a Charlie Kong. I used to sing that every morning at 4 o'clock in the morning. And then I ask myself now, why? Were we on the right side or the wrong side? And then at that point, you begin to question what is right and what is wrong. And then you realize, maybe I'm on the wrong side. If you take a look at the human condition, you realize that warfare has been an integral part of our evolution as a species. Even in the animal kingdom, animals will fight against other animals. And so my hope, however, is that we're different from the animals. We have a brain. We can make moral decisions. Animals do not understand the meaning of a moral decision. Animals is survival, is who's stronger, who has the food. We don't necessarily have to engage in that conflict. And so I would hope that we use the brain that we have to think through and create a better world. It's a version of the many worlds theory. But most many worlds theory simply says that there's an infinite number of universes and worlds out there, none of them necessarily identical to ours, but independent of us, that is a distinct possibility. Not necessarily. You can have an infinite number of things that don't repeat. So in other words, you don't necessarily have to have another civilization that is exactly like ours. You could, but it's not necessary if you believe in an infinite universe. It's possible when you look at the night sky, you're overwhelmed by the majesty of the night sky, and then you realize that we're nothing but a dot on this gigantic disk called the Milky Way galaxy. And if this is the Milky Way galaxy, then here we are thinking that this is the entire universe. There's nothing but a pinpoint on the Milky Way galaxy. And how many galaxies are there? We're talking about trillions of galaxies that are out there, each one containing roughly 100 billion stars. Well, I like to think of it slightly differently. I think on the other side of the Milky Way galaxy, there's an alien who's writing the same equation that I'm writing down right now in different language, in different notations. But he's also discovering string theory. And there are a lot of galaxies out there, each one with an individual saying, gee, I think I discovered something new about the universe. And these laws are universal. Now, are identical in different language with equations that they're writing down billions of light years from us. And that gives me a sense of oneness. It gives me a sense that, wow, we're part of a fellowship. We're part of a camaraderie. We're on the same quest, a quest to understand the nature of matter and energy. We're on the same boat. Even though we speak different language, even though we're on different sides of the universe, we're all part of the same club. Well, I like to look at it slightly differently. I say to myself, what is the smallest unit of history? And I say it's the decade. Anything smaller than a decade, you get random fluctuations, noises, accidents taking place in a decade. But if you look at human history, decade by decade by decade, you realize that, oh my God, just a few decades ago, it was horse and buggy. Before that, we just had plows. Before that, we were barbarians. And you begin to realize that we've come a long ways. Not that we hit the end, but we've come a long ways just in the decade by decade analysis of the history of the human race. Because before we couldn't destroy ourselves, now for the first time in human history, we have the potential of destroying ourselves with designer germs, with nuclear weapons, with perhaps artificial intelligence. We didn't have that capability before. And it's only been in the last 80 years or so as a consequence. So I think that, first of all, it means that every decade, tremendous progress is made. There's no doubt about that. But second, we're on a knife's edge. You tilt it the wrong way, and there's world war. You tilt it the other way, and there's food and luxury for everyone. And it's up to us to decide which way the knife will go. But my point is, decade by decade, we see the enormous progress that we humans have made. The next question is, what about the next few decades? That's a big question mark. Well, I think it's for certain that we're going to go not just to the moon, but to Mars, and maybe even beyond that. Maybe not in our lifetime, but in our grandchildren's lifetime, we may break through and visit other planets within our solar system. Now, to go beyond that would require some sort of warp drive, because of the fact that the nearest star is probably orbiting Alpha Centauri, which is 4.5 light years away from the planet Earth. So you realize it would take hundreds, if not thousands of years to begin the colonization of the nearby star systems. Well, it's what I'm seeking for my entire life. And that is, we want that one equation, which is the secret of the universe. We have the electromagnetic force equation that's like half an inch long. We have the equation for gravity that's also about half an inch long. So why not the theory of everything, maybe an inch long? We're not there yet. But I think it does exist. And if we were to find it, that would give us an understanding of the entire universe. And I think we're very close.
You think we're close?
I think we're close.
What makes you think?
Because so far, the theories that we do have, almost like magic, you look at the history of the equations of physics, and you realize they get simpler and simpler and simpler with time. You can write down Newton's equation, Maxwell's equations, the equation for the nuclear force on one sheet of paper. One sheet of paper. Gravity, we don't have that yet, but we have the other forces, and the equations are very simple. And that's why I think that the final equation will also be simple. When I look at the animals, that makes me triply impressed. The fact that animals cannot share in that we see a universe that the animals cannot see. We see patterns, we see meaning, we give rhyme and reason to what we see. With animals, it's just, where's my dinner? I think the universe is more fascinating No matter how fast we are with physics and the mathematics of physics, pure mathematics is still more profound. Well, I think we'll probably be on the moon, maybe onto Mars, and perhaps even dream about sending the first space probes even beyond that. We're talking about being able to use artificial intelligence to send probes out there. Of course, we're not going to go to the stars. That's a few hundred years into the future. But I think that we will begin to understand the solar system within this century. And this also means that we'll have artificial intelligence, a cure for cancer, and maybe one will aid the other. Maybe artificial intelligence will help us to cure cancer and many diseases. And longevity, perhaps we'll begin the process of solving the immortality crisis. And the telomeres are like a clock. They get shorter every time a cell reproduces. And when the telomere gets so short, it frays, falls apart, and you die. So we have a time limit. We've also discovered telomerase, a chemical that stops the clock. This was incredible when it was first announced, that if there's a clock in our body called the telomeres that tracks how long we're going to live, and there's something called telomerase which stops the clock, then can we live forever? Well, that was the good news. Then the bad news was we found out that to our shock, cancer also uses telomeres and telomerase to live forever. Why does cancer kill you? Because they are immortal. In principle, they could live forever. And so it means that the secret of immortality is tantalizing close. We do know that there are cells that make immortality possible, but there's a price to pay. The price to pay is you don't want cancers to also follow you. So here's the trick of the game. We have a whole bunch of top people in the sciences and medicine looking for ways to extend the human lifespan with the telomeres without...
What is this?
This is the future. This is a quantum computer. It's a computer that computes not on transistors, which is old-fashioned. It computes on atoms. Think about that. The ultimate object beyond the transistor that you can compute with is the atom. And so think of this as a cell. And the cell could either be switched on or switched off. If you take a computer and open it up, what do you find? Switches like this. They're called transistors. Transistors that tell you whether it's on or off. Mm-hmm. Now, that's digital. This is the revolution of today. This is the revolution of tomorrow. Not just up or down, of in between. How many states are there between 0 and 1? In principle, an infinite number of states between 0 and 1. So this is the basis of a digital computer. Mm-hmm. This is the basis of a quantum computer. Quantum computers are so powerful that even the CIA is worried that one day, perhaps in the future, they'll be so powerful, they'll be able to break into any known digital code. So even the CIA is worried about the fact that these could become so powerful that they'll allow you to break into any known computer. So these are called quantum computers. Why are they powerful? Because they compute not on transistors, they compute on atoms. And you can't get much smaller than an atom and have stable matter. But that's what quantum computers can do. And they exist. This is not science fiction. They already exist. Or down, on or off.
Kind of binary yes or no.
That's right.
Whereas...
And it turns out the CIA is following this work very carefully, because with this, you'll be able to crack any code. Why is it that a thief cannot steal your bank account today? It's because that thief does not have your digital code. If a thief has your digital code, there goes your life savings out the window. Capitalism would vanish. Society would come to a halt. There'd be civil war. There'd be all sorts of chaos taking place. But codes are there not to be broken. To break a code, you have to have another code. And so the CIA and other organizations create these very complicated codes that you have to master. Quantum computers can do it. But we're not there yet. But it's coming. I don't know when. Some people say in a few decades. Some people say sooner. I don't know. I just know that the world is gambling that we'll find a way to stop quantum computers from breaking into digital computers. Well, I was fascinated by the work of Einstein and the work of people working on subatomic particles, and I got interested in antimatter. When I combine matter and antimatter, I get a bomb. So you have to be very careful that you don't marry matter with antimatter. And antimatter behaves the opposite of ordinary matter. If ordinary matter goes clockwise in magnetic field, antimatter goes counterclockwise in that same magnetic field. And so as a science project, I wanted to photograph the tracks of antimatter. So I got hundreds of miles of copper wire, built a cloud chamber, and I was able to prove that I could photograph the tracks of antimatter. And for that, I won grand prize at the San Francisco Science Fair, and that began my career. Just before I graduated from high school, I decided to top that by creating an atom smasher, a 2.3 million electron volt betatron particle accelerator. It consumes 6 kilowatts of power. Everything that my mother's house had, it would absorb. And that was the goal, to build a machine that would create my own beam of antimatter. So I got started very early, and I said to myself, this is for me. This is what I want to do for a living. No, but the one thing that did change my attitude toward life, other people, was being in the Army. Yeah, that was a game changer that changed everything I knew, or which I thought I knew. Before then, I was single-mindedly focused on physics, just physics, do physics well. That was my life. But after seeing warfare up close, I began to realize there's more to life than warfare. That's
and actually,
right. What you see, your conception of the three-dimensional world is only the tiniest sliver of actually exists, because your brain, your personality, your thoughts are electrical. And when you die, the electricity turns off. There's nothing propelling thinking anymore. Thinking requires a lot of energy. Even ghosts, if ghosts exist, they would still require a lot of energy to keep the thoughts going. But that's why I don't believe in ghosts, because I don't see an energy source that propels the ghosts. I think it's psychological that you are tuned into a certain personality, a certain way of movement. I think it's psychological rather than physical. Well, there's a lot of things that haven't been proven. All I can say is maybe, maybe not, like flying saucers. I don't say they don't exist or they exist. I say maybe. I just haven't seen concrete evidence for them, that's all. So there's a lot of things that I'm not going to definitely say no, like ghosts. I don't think there are ghosts, but I can't prove it. Maybe there is some afterlife of some sort, but it does go against what is measurable. We've seen no measurement of somebody that's been able to pick up vibrations from a ghost. Well, I care about leading a good life that I feel comfortable with. Mm-hmm. And if your books and your teachings and your lectures, if they live on beyond you, that's a bonus. It means that you had an impact. It means you touched people. You touch people's lives with ideas. And when I go down the street, quite a few people come up to me and they say, I saw you on this show. I saw you on that show. And that gives me a nice feeling. Of course, after I'm gone, there's nothing to feel. But when you're still alive, it gives you a nice feeling. Know that you've had an impact. Knowing that you've changed somebody's life. Several people have come up to me and said, I became a physicist because of you. So that's a nice way to view reality, that you touch people. Well, I like to debunk. So as soon as someone says something outlandish, I say to myself, sure. But usually when I make predictions, they come out to be true. Maybe the timeline is a little bit exaggerated, but they turn out to be true. So I haven't made any predictions or observations that were later shown to be false. Well, I talk about the nature of string theory in the future, whether or not we really will have a theory of everything. Flying saucers, I talk about the fact that even though we have no evidence today, there's a mountain of these things being declassified now. Maybe we'll pick up shreds of evidence. Yeah, I've looked at the whole batch, 160 or so sightings. It's dancing in the sky without any commentary, so you don't know what they are. but they could be extraterrestrial. But you see, these things are two-dimensional. They're taken by a camera, which is flattens the image. Therefore, to judge distance is very tricky. I'm open to the idea. I don't think there's any smoking gun yet, but I'm open to the idea that these are extraterrestrial. I leave open the probability that it could be one or the other. There's no aha moment where I say that it's nothing but reflection, it's nothing but an optical illusion. There's no aha moment. No. Maybe, yes. Very important, the word maybe. I'm a scientist, and somebody's going to use that against me by saying, you said on television that this and this is true. No, I said maybe. That doesn't mean it actually is true. It just means I open the possibility that it's true. I think the best strategy to deal with failure is try it again. I think on the first try, you're bound to make mistakes because it's a learning curve. And that learning curve is instructive. It teaches you. It teaches you to try it again, but make a slight change. Make a slight change and hope that change is in the right direction. If not, make another change and see whether that puts you in the right direction. I'd say carry on. I've made a lot of decisions that I feel good about. Decisions that made me a better person. For example, when I went into the Army, at that point I thought, what could be worse than facing death on the battlefield to die on some unnamed hill in some unnamed land? And then I began to realize, well, yeah, that's a possibility. But there's another possibility that you may survive, that you may learn from that experience. If you're not here to learn, okay, so be it. But if you are here to learn, you gain wisdom by being in the military. And that, I think, is a positive thing. Well, if I were to shoot in the dark, I'd say, first of all, they're robotic. They're not organic at all. Maneuvers that would crush the bones of any living creature that we know of. These flying saucers can zigzag. They can dive from 70,000 feet all the way down. They can dive underwater. These require skills and tensions and vibrations that would crack any known U.S. device in half. And there they are, executing these things. Either they're fake or they're extraterrestrial. So I think that they have a technology that we can only dream of. That's right. In fact, that's probably one reason why they don't come out and greet us like in the movies. In the movies, they always come out and say, hello, Earthman. No, I personally think they're robotic. Will they destroy us or will they want to? The answer, I think, is no, because they could have done it years ago. You realize that if you go back, even the Bible makes reference to a UFO. If you take a look at Ezekiel saw the wheel in the sky. And some people say that was no wheel, that was a UFO. So who knows for sure? But if the aliens really wanted to destroy us, they could have done it years ago. They don't have to wait. But if you go to a zoo, even if the zoo is lifelike to the point where the animals themselves don't even know they're in a zoo, it's peaceful, that you can observe them without necessarily revealing your presence. And in that sense, it could be like living in a zoo. Not that they want to gawk at us and laugh at us, but just observe us. I think if they had the chance to destroy us and they wanted to, they could have done it decades ago. But here we are. My personal attitude is that we should eventually merge with them. That's my personal feeling. Because people talk about whether they're good, whether they're bad, so on and so forth. Well, the bottom line is they're going to become more powerful. And not now, but who knows, maybe in the next century, they'll begin to make reasonable choices. They'll reason. They'll plot future histories. And at that point, they could be potentially dangerous. So what do? Either we become super powerful and meet the challenge, or we merge with them. Yeah, in other words, we are still looking the same, except we have superhuman abilities, and our brain is connected either directly or by remote control to a central nervous system that does the calculations and performs these calculations much better than we can, and we become superhuman.
This is the video that I'm talking about. This is actually a live video. So this is live as we're watching.
Directing other people. Robots can't do any of that stuff. Robots simply do what they're told to do, repetitively, okay? We make decisions, We know how to interface with other things. We plot, we plan. Robots can't do that. So that they can become masters of the robots. In other words, we are masters of tools, hammers, saws, whatever. We're the master of them. They're not the master of us. Okay, we tell the hammer and the chisel what to do because we lord over them. I've used AI before, but not necessarily. Which agent are you talking about? Well, I can just type on the computer screen a question, and the computer will come up with an answer.
But,
you mean not just coming up with the plan, but actually executing the plan?
Yeah. It can do both.
No, you tell it what to do. The computer is probably programmed to look for a reference, like an encyclopedia, a handbook, the internet. In other words, if you say, I want to know the best car, it'll carry that out by looking at the internet, going through But if you were to ask something more complicated,